Assalamualaikum warahmatullahi wabarakatuh. First, let me begin with the introduction. Vector is one of the most important topics because it helps us describe quantities that have both magnitude and direction, like force, velocity, and displacement. Vectors are not only used in engineering, but also in our daily life. For example, when we walk, drive a car, or even kick a ball, we are actually applying the concept of vector. That's why understanding vector is very important for engineers and also for solving real-life problems.
Application vector in our daily life. For example, in civil engineering, vector help to find the resultant force on a bridge. In electrical engineering, they are used to represent voltage and current in AC circuit. In mechanical engineering, vector are used to determine torque and motion of machine. In our daily life, we also use vector without realizing it. When we walk on a right of vector. When a football player kicks the ball, the strength of the kick is the magnitude and where the ball goes in the direction. Even when an aeroplane flies, it uses vector to control direction and wind speed. So vectors are not just number, they are represent motion, balance and direction in everything we do.
So, for the problem statement, in the study of physics, many physical quantities are used to describe motion, force, and energy. However, confusion often arises when distinguishing between scalar and vector quantities. Scalars have only magnitude, while vectors have both magnitude and direction. This difference is crucial in solving real-world physics problems such as determining displacement, resultant forces, or velocity. Students often struggle to understand how vectors combine or differ for scalar, leading to errors in problem solving and experiment analysis. Therefore, this project aims to identify and differentiate between scalar and vector quantities, demonstrate how vectors can be represented graphically and mathematically, apply vector addition and resolution in real-life physics situations.
Operations vector. As you can see, there is Ipoh Parade, Polytechnic Ukuoma, and Masjid Sultan Azlan Shah. A to B, it took 3i plus 2j, but from B to C, it took 5i plus 7j. First of all, Nabil walks from Ipoh Parade to PUO with the displacement vector of A to B. Second, from PUO, he goes to Masjid Sultan Azlan Shah with the displacement vector B to C. The resultant displacement is that Nabil has walked from Ipoh Parade to Masjid Sultan Azlan Shah A to C. The resulting displacement vector A to C is called the sum of A to B and B to C. Therefore, A to C is equals to the A to B plus B to C. Okay, now for the calculation part, we can see that there is Ipoh Parade, Polytechnic Ukuoma, which is PUO, and Masjid Sultan Azlan Shah. A to B is given 3i plus 3 plus 2j. From B to C, it is given 5i plus 7j. This is the given numbers which I told just now, and find A to C. A to C is equals to the A to B plus B to C. A to C is equals to the 3i plus 2j and 5i plus 7j. And if we total it up, we will get 8i plus 9j. That is the answer.
In conclusion, vectors are one of the most important tools in engineering mathematics. They help engineers analyze and solve problems involving direction and magnitude. With vector knowledge, engineers can design structures that are stronger, safer, and more efficient. Thank you for watching our presentation.